Hello, everyone, and welcome to the first webinar of our Copernicus Hub's Essential series, focusing on the Coastal Hub. My name is Marine, and I'm a Training and Capacity Development Officer at Mercator Ocean International. I'll be one of your hosts for today. During this session, we will give you an overview of the Copernicus Coastal Hub, its features, and the data available on it. Guest speakers will also present 2 projects developed using data available on the platform. We'll end today's webinar with a Q&A session, during which all speakers will answer your questions, so stay tuned until the end. By the end of this session, we hope you'll feel confident and well-equipped to start exploring and using the Copernicus Coastal Hub on your own. Before we begin, let's quickly go over some house rules to make sure that you enjoy this webinar to the fullest. Please don't use the chat box on your right-hand side for questions. It's there for quick greetings or casual exchanges. Don't hesitate to tell us where you're from, what you do. If you have a technical or content-related question, we invite you to use the dedicated Q&A section. You'll find the Q&A button at the top of your screen. Simply click on it to open the dedicated space where you can ask your questions to our speakers. We'll have a single Q&A session for all speakers at the end. So when you submit a question, it will be really helpful if you mentioned which speaker it's for. And while you're there, you'll also see a quick survey about today's webinar. So feel free to fill it out anytime during this session. Finally, we also encourage you to visit the guidelines and resources section on the event website. That's the website where you're registered to join this event. You'll find useful links to the materials and tools we'll discuss today, links to the website of the projects that will be presented today, for example. And now I will hand over to the second host of today's session, Daria Andrievskaya from Noveltis. Daria, can you hear me?
Yes. Do you hear me?
Yes, we can hear you.
Great. Thank you, Marine. And hello, everyone. I'm Daria, and I'm going to be your second moderator for today. And I'm going to start with presenting our speakers for today. Well, you already saw me, Ian, Marine, and our speakers. We have 4 speakers today. First one is Muriel Lux. She's from Mercator Ocean International, and she will be the first to present her presentation about platform tools. Then next we'll have Alexandre Boras, who is also from Mercator Ocean International. He will show you also some tools from a platform as well. And then we'll have our 2 use cases, which is first going to be Marija Gai from High Tech Imaging, and then Fabian von Trentini from EOMAP. And they both will present their own use cases, their own projects, and we'll have a panel discussion with both of them. And we will finish with a Q&A session with all the speakers of today. And for the first presentation is, Introduction to the Coastal Hub by Muriel Lux. And Muriel, do you hear us?
Yes. Do you hear me?
Yes, we hear you. Good.
Okay. So let me just, you have a problem with my, okay. So I'm going to share my screen now. Thank you for the introduction. Is that okay?
Yeah, we can see your screen, but maybe you can
presentation mode.
Go in presentation mode. Yeah, okay.
Okay, so good morning, everyone. Thank you for joining this webinar dedicated to the Copernicus Coastal Hub. So I'm Muriel Lux, working at Mercator Ocean. I was responsible for the implementation of this Copernicus Coastal Hub. So just to provide you a bit of context and objective of this initiative, This initiative for the implementation of thematic hubs come from the European Commission. The objective was to facilitate the access to Copernicus data by thematics and to serve core user, but as well scientists, private sector, international organization, etc. So the main objective of the thematic hub is to help implement EU policies, cross-fertilize between service to develop new types of use, facilitate the use of Copernicus at national and local scale, foster the use of digital solution to create added value information, and help easily identify information gaps in the service, because the hubs are also meant to collect needs from the users. So regarding the Copernicus thematic hubs as a whole, there are 6 now. They have been launched in November 2023 in Sevilla at the EU Space Week. These hubs are the Health Hub, the Coastal Hub, the one we are talking about today, the Energy Hub, and the Arctic Hub. So Mercator Ocean International is in charge of developing the Coastal and the Arctic Hub. So the development of these thematic hubs are made through the contribution of the different Copernicus service, the 6 of them, the atmosphere service, the marine service, us, the land service, the climate change service, the security service, and the emergency service. So this is an overview of the content of the Coastal Hub. So what is the Coastal Hub? The Coastal Hub is not a new database with new product. It's simply a new entry point providing access to data for coastal zone from all Copernicus service and sentinels. So it addresses all the I would say all the environmental aspect of the environment, the environmental aspect of the different services. So you can find there parameters from the geosphere, from the atmosphere, from the biosphere, the hydrosphere, and the cryosphere. So how does it work? We interact with the different Copernicus service to select fit-for-purpose data for coastal zone. So each of the Copernicus service include many products. And here the idea is to provide a selection of these products. So we do not create a new database. We are directly plugged to the different Copernicus service. And when you explore the Copernicus Coastal Hub, you will reach a catalog that include the products from the different services. So on the right side, you can have access of the catalog, and then you can see that you have, for example, from the climate change service, 40 products, about 40 products, from the atmosphere, 13 products, etc. So when you reach the Coastal Hub page, you will have access to the main page on the left side, and this will give you access to the data that are directly plugged to the different Copernicus service. You will find there a visualization tool. I will show you after that. You will also access a portfolio of thematic use cases showcasing how Copernicus data serves decision-making, different kind of use according to main topics we have defined. Topics, for example, for the coastal regarding water reservoir, water quality, all topics regarding pollution, spatial planning, coastal erosion, aquaculture, and so on. So the address to reach the Coastal Hub is the following one. So this is, but we will see that in the future presentation, the next presentation. This is some example of view you can build from the visualization tool. You can visualize, for example, here, concentration of chlorophyll at high resolution and the coastal land use in different region. Here you have the salinity coming from the Copernicus marine product, and you have also the land use. So you can have you can analyze the data by combining different kind of information. That's really interesting. What I would like to mention here is that to encourage the development of downstream service for the hubs, we at Mercator, we regularly launch some call for tender. So the last one was launched last year, and different projects were selected. 5 new use cases are available in the page of the Coastal Hub. So the next call for tender will occur in January 2026. So it means that we have some requirement for this call for tenders. We ask that the candidate, the tender, propose downstream service that are useful for policy maker or decision making, that they are aligned with the different themes of the Copernicus hubs. It can be spatial planning, water quality, and so on. And the idea is that the service must use products from at least 2 or more Copernicus service, and at least one from the Copernicus Marine, of course. So stay tuned when we launch this call for tender on our website. Now, if I want to show you a simple visit of the website. So here we go. You see my screen. This is the landing page of the Coastal Hub. So here in the main menu, you can reach the visualization tool and how to access and download the data from the different Copernicus service. You have the page for the example of use cases, and you have also a user corner because we have a powerful user support to accompany to support the users in their search for product information. So the Coastal Hub is a very simple website, not with very many scientific explanation. The objective is to really support easily and not with too many information the users to provide a bit of guidance. So maybe I can show you first the use case page. So here you find again what I showed before. If you select, for example, the water use case or the use case related to water, you will find some different information regarding the different use case submitted to the Coastal Hub. And here you have the logo mentioning what kind of product have been used for each of this use case. And if you click on the use case, you reach more information related to this use case and useful links to reach the service. Okay, so and you have this kind of example for the different topic. If you go through the visualization tool, you can reach what I showed before, the full catalog of product, and then you can select per service, per variable, per parameter, and per region. So I think that you will have some demonstration after that. I think that's it from me regarding the hubs. So I thank you, and if you have any question, I will be pleased to answer. Thank you.
Thank you very much for your presentation. And yes, before question, we will have a Q&A sessions at the end of today's webinar for all the speakers, including you, Muriel. So now we are moving to our next presentation, and it actually follows very nicely because it's about viewer demonstration, and it's going to be Alexander who going to present it. Alexander, we see you and we hear you?
Yeah.
Yeah, okay, great.
Thank you, Dario. So hello, everyone. I'm Alexander from the Costa Hub user support. And today we are going to take a look at the Costa Hub. Sorry, let me share my screen first. So we'll take a look at the Costa Hub data viewer. I will show you how to search for the data you are interested in. We will show how to visualize and download it. And we will also go through the interface and tools so you can get more comfortable using the platform. So let's meet on the Costal page that you can find at the link costal.hub.copernicus.eu. Here we will navigate to the data viewer at the top right, clicking on this. If it's the first time you reach this page, you will have 3-layer display by default. So the first one is the seawater potential temperature in degrees. So we have this eye icon on the left that allow you to hide or not the layer. You can change the date at the bottom of the viewer with the time bar. So if you want to get more precise choosing your date, you can scroll with your mouse scroll, or you can use, if you're on the laptop, the trackpad to zoom by scrolling the 2 fingers up and down. So like this, we can choose a more precise date. And when we choose the date, the data will be updated on the viewer. Sorry. Then we have the coastal zone layer. So if you want to zoom in a little to see this layer, we will go in France near Marseille to better see this layer. We will hide the other layer to better highlight this one. Sorry, the resolution will be updated. Sorry, my connection failed to update the resolution. But on the left, you have the legend of the data. So with all the information about it. And then we have the EU Hydro River Network. Sorry, I have issue uploading, getting the layers. Yeah, that's the blue ones that highlight the rivers, and also you have the legend of this dataset. So let's now reach the Coastal Hub catalog. You can click on the plus next to the layers tab right here. So on the right, you have all the datasets available, more than 100. So here we have the name of the dataset. Here you have the number of layers that can be displayed on the map. For some dataset, like here, you can have an eye icon that show you that this dataset is not viewable, but it's still downloadable and subsettable. Then we have the star icon to add a layer to your favorites that you will find on the left. You have the thumbnail that show you what the data will looks like once you add it to the viewer and also once you download it. Then on the left, you have all the filters. The first one is the free text search bar that that allow you to search the dataset with keywords. Then you have the Copernicus service. Here we have 5 of the Copernicus service. The Copernicus Marine is the one that is that give most of the datasets. Then we have the area and many tags. So for today, we will choose a Copernicus marine dataset in the Mediterranean Sea. And we will choose this one, the Mediterranean Sea Biogeochemical L4 monthly means and interpolate daily observation. This dataset has 3 layers viewable on the map. So we click on details to have more information about this dataset. Here is the title at the top. Then the abstract with many information about this dataset. You will find a link to the documentation. Depending on the providers, you will find this link or not. Then you have the dataset ID. This is very useful if you want, for example, share with someone which dataset you are using. This is a unique name using unique dataset ID. So if you share this, you will know exactly which dataset you are talking about. Then you will find the Copernicus service, the area, and the metadata. At the top, you have the temporal extent, the latitude and longitude extent, and you have this WMS WMTS link. So if you click on it, this allows you to access the link that will allow you to integrate the dataset into external GIS like QGIS. So you can copy the link right here with this button. And now let's add a layer to the viewer. So let's add the first one, the mass concentration of chlorophyll A in seawater. So you can click on Add to Map, and then you can click on the cross button or outside of the window. So right here we have the layer we have added with its name, the units, milligram per cubic meters. Then you have the date at which we display data, the area, and the color bar. So let's hide some of the other layers to better highlight this one. So as I said, at the bottom, you can change the date of the data display. So let's take something like in January 2025. And here we can see that the concentration of chlorophyll increase at the intersection with this river, which is the Rhône in France. And now let's talk about the button at the bottom right. So the first one is the equatorial tool to change the projection from equatorial to polar north and also polar south. Then you have the point tool to display the coordinate of a point. And it also opened a panel showing time series graph of the available data at that location. It's a useful way to explore how the values evolve over time for a specific point, but this feature is not available for all datasets. Quick tip, you can press escape on your keyboard to remove a tool from your hand, like so. Then you have the measure tool to calculate the distance between 2 points, like so, 2 or more. Then you have the set AOI, so area of interest, to draw a bounding box on the map. This is very useful, as we will see after, because this will allow to set this bounding box into your download parameters to download data only in this area. So we will keep this bounding box draw on the viewer. And then you have the settings button to show or not the base map, as you can see, show or not the coastline and reference features, change the units, for example, from kilometers to miles, same for area. And you have the credits. Now let's talk about these buttons. So this one is the log button to enable the log scale. I have some issue updating data in this training, sorry. Then we have the setting to configure the layer, so we can change the opacity. This is useful if you want, for example, to compare 2 datasets at once. Then you have the possibility to change the color map if you want something that more highlight the data, for example, this color. And then you have the min and max values to focus, for example, on higher data. So here I set a higher min value to better highlight higher chlorophyll concentration. It's not for today. I can't update. But never mind. We will keep showing like it was. Then we have this button to change the layer. So here we have the layer that we are displaying, but you can change right here for the 2 layers that this dataset propose. And then we have, just quickly try to update the data. Yes, like this. And then we have so the details button to go back to this page where we have all the information on the dataset. And then the download subset and download button. So if we click on it, you will find the parameter to download our data. So the first one is the bounding box. You can enter manually the decimal degrees of the bounding box you want in all the projection orientation, sorry. But you can also, as I said, copy the area of interest from the map by clicking on this button. So it will enter automatically the coordinate of this bounding box. Then we have the variables parameter. As you can see, there is a red asterisk that indicates that this parameter is mandatory. If you don't select a variable and you request your data, you will find an error message that some fields are missing or invalid. So you need to select one of the variables. So we choose the mass concentration of chlorophyll A in seawater. Next, there is the start and end date. So you can select the date with this calendar, or you can copy from the layer the date. For example, here, 7 January 2025, if I copy from layer the date, oh, we are not in 7, we are 8. This will automatically select this date from the time bar at the bottom. Same from the end date. If I want to take, for example, 1 week after, I can copy from layer. And then we have our two start and end date. Then you have the license that you will need to agree to request your data. You can click here to show the license. And then you have two buttons. The first one is the show API request button that will display here our request. You will find all the parameters you have set before. This is very useful if you use the API request. So our tool is the Harmonized Data Access API. This is part of the Wikio infrastructure. So if you click on the HDA documentation, this will redirect to our Wikio article about how to use the HDA API in Python, but you can also use it in R or with the REST API. And this allows you to download data programmatically. And as we will see after, if you have many results, the API request is a useful tool to download all results at once. And then another way to use the API request is if you have an issue and you want to share it with the user support, you can copy paste the query to user support, and we will be able to replicate the issue on our side to better investigate it. Now let's click on request data to get our results. So it's running depending on the time, and then you have the request thanks to successfully message at the bottom right. This can take seconds depending on the size of your request. And you will find in the jobs tab right here all the requests you have made. So here is the last one. You will find the name of the layer from which we subset our data, the date and time at which you made it, and a status. So here is completed. And same thing, if the request is more important, it can keep running for seconds. but once it's completed, we'll have access to the results. Here we have this button to display the API request. This is here very useful if you don't remind which parameters you have put to get these results. You can click on the button and show which parameter you have filled in before. And then you have the folder icon where you can find the results. So here you have one of one result. You can find the name of this item right here. As this is a Copernicus marine dataset, we have a netcdf file, just one. And here we have the date of the data we want to download. This is the, if you remind, the start date right here. Then we have the size of the file. And if you want to download this item, you can click on order. It will keep running for seconds, sometimes minutes, depending on the size of the file. And once it's done, you will have a downloadable icon that will allow you to download the results on your computer locally. As today I have maybe issues. Yeah, you have the download icon. So if you click on it, this will redirect to your local files where you want to download the data. One important point, as I said, here we have only one result, but sometimes depending on the provider, you may have maybe hundreds of results. And so the API request and our API, HDI API will allow you to download programmatically all the results at once. On the viewer, it's actually only possible to order the results one by one. So you will need to click on order on each of the results and then download them one by one. So this is where the HDI API can be useful. And I think is the widget chat. From there, you can access our articles. You can search with keywords. And also you can browse our articles if you have questions. And then you can also send us a message if you don't find the information you want and you want to talk with us. And that's it. Thank you for your attention. And if you have any question, don't hesitate.
Thank you very much, Alexandre. It was very interesting and I hope useful for our participants. So now we are moving to our next presentation, and it is a presentation of Litosat project by Marie. Marie, we can see you and
yes.
We can hear. We
can you hear me?
Yes.
Perfect.
You can start sharing your screen.
I share my screen.
Yep, we can see it.
Can you see the presentation now?
Yep.
Okay, great. Thank you and good morning, everybody. Thank you to the Coastal Hub organizers for the invitation. I'm very happy to present our work today. My name is Marie Jagaille and I represent High-Tech Imaging. High-Tech Imaging is a French company created in 2016 with the ambition of developing and democratizing the use of spectral imaging, including satellite imagery. And our team has an expertise in radiative transfer, and our main thematic applications are related to coastal applications. We provide our customers with mapping and monitoring products and customized solutions based on imagery. And my presentation today will focus on the Litosat solution. Before introducing Litosat, here are a few background details that led to the development of this solution. French municipalities, the smallest administrative units in France, have a high concentration of inhabitants with 8 million people. These areas are therefore subject to many anthropic pressures, and a national survey estimated that almost 90% of coastal habitats are not in a favorable condition. On the other hand, the state has tools at its disposal, such as marine protected areas, which cover almost a third of France's maritime space. And within these marine protected areas managed by the French Biodiversity Agency, coastal stakeholders need tools enabling a regular monitoring in space and time. Firstly, to assess the effects of climate change or the effect of local pressure. Secondly, to assess the impact of local policies aiming at increasing resilience. And thirdly, to provide as much as possible early warning systems. In this context, we have developed a first version of the Litosat dashboard based on Copernicus and Sentinel-2 data with several objectives: to produce relevant datasets which are available for free with low production costs and fully automatic processes, to distribute this dataset via an online interface, and to use this dashboard for co-design with coastal stakeholders in order to set up our APA commercial offer. And we started by developing the dashboard in 2 regions of France, and we developed our first use cases on coastal vegetation. One of our pilot region is the Brittany region, subject to strong tides and counting 800 square kilometers of foreshore. This foreshore is hosting many habitats of interest, such as the mudflats or seagrass beds. And this is an area that really needs to be better known and monitored. And to date, the only global data available at the national scale for the foreshore is an orthophotography at low tide with a frequency of every 7 or 10 years at the national level, depending on the region. And with Litosat, we provide a unique seasonal Sentinel-2 image composite, Tidal S2. And with Tidal S2, we offer a dataset with an unprecedented frequency of updates. The revisit of the Sentinel-2 satellites allow us, taking cloud coverage into account, to have a nearly complete mosaic for each season with a resolution of 10 meters. And derived from this composite layer, we provide a vegetation index for emerged areas, IVS2. We will have a look at a coastal spit in Brittany, a coastal spit bordered by a rocky reef, with the screenshots from the Litosat viewer, with a zoom on the Tidal S2 winter composite at high tide and at low tide. The foreshore is the area between the green and blue line, and we can, on the viewer, display the vegetation index with a red color map with areas covered by vegetation, in this case microalgae in red, and rocky and sand coverage in yellow. And the production of this mosaic, this regional mosaic, is fully automated. And by automating the process, we can display a new Litosat instance distributing Tidal S2 and IVS2 seasonal data in a region within a few weeks. In addition to these datasets, we offer a viewer. It's open and free and based on an open source solution. And it allows us to display and describe Tidal S2 and IVS2 datasets and link to the metadata. It also allows additional datasets to be displayed. In this case, for example, we can see the areas covered by protection measures, such as marine protected areas in blue, regional park in green, and areas of the Natura 2000 network in orange. We will now focus on a use case developed for monitoring an invasive species, Spartina, that colonize mudflats in Brittany. This use case was developed with 2 local partners, a regional park and a research laboratory. And I will use a video demonstration of the viewer to illustrate the use case. The regional nature park was perimeter is shown here in green. Here is facing colonization by this invasive species, which is developing in place of protected endemic species on the foreshore. So with our partner, we choose to work on a study area here to evaluate the contribution of Sentinel-2 images to better understand the intra-annual dynamics of the species. First, we run our API that is currently available internally to select all available cloud-free Sentinel-2 images. The results is shown here with a dozen of cloud-free Sentinel-2 images for the demonstration here. We automatically extracted the vegetation index visible here on the green maps, and we conducted an analysis on the polygons delimiting the Spartina coverage, visible here. These polygons were provided by our partner, the Regional Park, which produces accurate maps based on the GPS surveys. You can see here some illustration of the survey on the field. And also, they use a GIS photo interpretation. Here you can see extracts from the mapping reports and some picture of the Spartina in the rear. The inventory data produced by the regional parks have been integrated into Lithosat. Here you can see the map and the integration on Lithosat. And this allows users to familiarize themselves with the information contained in the images, displaying vegetation index in summer, in spring, in autumn, and in winter. These intra-annual trends can also be visualized in graphs. We calculated the average vegetation index for each polygon over the year. And the graph highlights a sudden increase in the vegetation index here in spring, which reveals the early phenology of Spartina grass. The vegetation cover, excuse me, just a little problem with my video. Up. So, the vegetation cover of Spartina grass disappears in winter, as many other species, and however, Spartina reappears early in the spring. This gives an advantage over other species which no longer have free substrate on the mudflat to grow on. We have also integrated data from the Copernicus Marine Service, not in the form of a map, which was not really relevant for our end user, for our partners, but directly in the graphs. So we reused the sea surface temperature and the mass concentration of chlorophyll. This data is directly available to users, and it provides contextual information on global changes. And we can see the evolution of the sea surface temperature in red and the concentration of chlorophyll in purple on the graph. Now I will give you some feedbacks about this use case. It has enabled us to implement new tools for querying data in Lithosat, making it easily to our partners who are not experts in image analysis or in coding. And we plan to continue the study with botanists, experts in phenology, to further explore the link between temperature and Spartina dynamics. And the park, the regional park, has also expressed a more forward looking need for an alert service, for which we need to consolidate our processing chains and our models. And more generally, we will continue to develop use cases that help us specify the specification of our APIs for territory managers, And we will carry out this work within the framework of the Coastal Hub with a second use case currently being finalized on macroalgae. And we will also continue to extend the space coverage of the composite products, Tidal S2 and IVS2 in France and in South Africa with the support of the French and South African space agencies. And in terms of perspectives, we will also continue to work with working groups, bringing together coastal stakeholders at broader levels, regional or national, because it's really something needed for specifying a standardized product. And this work will be carried out as part of the National Coastal Zone Satellite Monitoring Program, an ambitious program involving all coastal stakeholders in France, and which will run for 3 years. And it will enable us to extend the scope of Litosat beyond vegetation. And also, it will also address morphodynamics and water quality issues. My presentation is over. Here you can find the link with more information about Litosat and my contact, and also Mark Lennon contact. Feel free to contact us if you have any question.
Thank you, Marie. It was a great presentation. I think we will have questions for you from our participants, but later. Now we are moving to our last speaker for today. It's Fabian from EOMAP, and he's going to present Advice for Coasts project. Fabian, you can hear us, you can see us, we can see you.
Yep. So
okay, great.
Yep, all good.
Yeah.
Welcome everybody. My name is Fabian from German company EOMAP. We are specialized in aquatic remote sensing. So we do a lot of things around water that you can do with satellites. And I want to talk about something quite new for us. So we usually produce our own data sets based on our algorithms that take the raw satellite data and provide something like we heard about chlorophyll, turbidity, and all these things already. But we always want to go a step forward, and in this case, this is about the integration of Coastal Lab or Copernicus Marine data in more general for a lot of different users, but the target here is mainly the authorities that are obliged to go to report to directives like the Marine Strategy Framework Directive in coastal zones. And this is what I'm going to talking about now. So more general, maybe the role of Earth observation in this EU directives context. So the these authorities, usually something like an environmental agency, they have the obligation to assess ecosystem health, water quality, and also the effectiveness of measures that have been taken in terms of management to acquire, in the end, better water quality and better ecological state and so on. And while this is usually done with in situ methods, and they of course have a lot of advantages, there is also a benefit from the integration of Earth observation or also modeled data into this context, because in situ measurements are always point measurements, and they're usually scarce. And as we see on the picture on the left, just as an example, the coastal environment is very dynamic, and doing point measurements only tells you half of the story, I would say. And the Earth observation can come in and give you a more broader picture. You get spatial variabilities better. You can also look at regions that you cannot go to, for example, or that are harder to reach. And you also get the big picture in terms of time series. So you can go back in time with Earth observation and modeling that I will show in a minute. And the targeted EU directives, I already talked about the Marine Strategy Framework Directive, but also bathing water, so algae blooms in coastal areas, as we see on the picture, Habitat Directive, and the Water Framework Directive as a more general one. So the challenges that these authorities usually face, that the monitoring usually has gaps, as I said. In situ measurements per se are only point measurements, so you have a lot of blank space in between, and it's really challenging to do these samplings at many locations. On the other side, the climate is changing, environmental behavior might change in the future even more. So maybe all the things you think you know about the water body or the coastal zone that you're acting in might not be true in the future anymore. So it's even more more extremes, maybe more algae blooms expected, or less of something. Also possible, of course, not always more. So you need to adapt to these things, and maybe using new other data sets that you haven't used before is one of the ways to tackle these challenges, especially if we talk about lack of funding and lack of personnel, because in our experience, from what we hear from our customers, usually is they can't do sampling as they want to. They don't have the personnel, they don't have the time, they don't have the money to go out in many sampling campaigns and do everything that they want. So this is where this Earth observation or model data from Copernicus Marine or other sources comes into play. Very short about the project itself. It's part of this Coastal Hub Uptake program, runs for these 1.5 years. We're at 1 year at the moment, so we're quite into the project already, but it still runs for half a year. So this is not where we stop. All the things that I will present are only the status of about 2/3 of the project, and there's even another project on top now that adds more functionalities, more cool things on top. We've developed this, or we're developing this together with the LUNG, which is the German acronym for the State Agency for Environment, Nature, Conservation and Geology in the northeastern German province of Mecklenburg-Vorpommern. You see it in the map, so it's in at the Baltic Sea coast of Germany. And what are the duties of this agency? Water quality monitoring, of course, also managing all these data sets that they acquire, and then finally reporting to national or EU authorities. The challenges that they have are, and the challenges are now talking about not about their in situ sampling, but more about third-party data, like what we want to talk about today. So the data availability and accessibility. And the reporting, which is the ultimate goal, is not supported by efficient data collection at the moment. So they're kind of struggling with these data sets, and I will go into detail in the next slides. We've seen the data catalog from Coastal Hub. The one from Copernicus Marine is even larger, but you see on the very top, it says datasets 140. You have these filter possibilities, but once you click on the biogeochemistry, for example, a lot of more products and variables open, and even for experts, sometimes it's hard to understand all these different data sets, and it can be overwhelming, although we've seen there are nice tools to download the data, to visualize the data. But at a certain point, that's what our experience is, that users are overwhelmed by all these data sets and they can't really handle it, also because they don't have the personnel and the time to really dig into that. And that's the basic idea. We want to simplify the access to these great data sets that are all stored there. This is done with our web application. We call all of our web applications EO apps, so Earth observation apps. This one is called Advice for Coast app at the moment, but it builds largely on our operational water quality app called EO app Aqua. And what it does is it gives you access to selected variables. That's the first thing. So not all these parameters, but only the ones that are useful for the application in discussion. And this can also be individualized for each user. And then we have this really nice app that goes a little bit beyond what is possible in the Copernicus in the Coastal Hub viewer. So we have some more tools and analyze dashboards that show you, we call it baseline, which is a historical analysis, monitoring alerts, so you can define thresholds for certain areas. If something, a threshold is exceeded, you get an alert, and some more features to quickly analyze these data piles. So what we want to do is move from data to something we call rather an information product. So if a user wants to, usually doesn't want data, right? They want information. And this step is really important to really generate uptake of all these great data sets. And this is, in our experience, really one of the main challenges that people face. On top of that, you can include in situ data. So basically any point data set can be uploaded as a CSV file, more or less, and can be displayed and also shown together with the other data sets. We can also include the water quality products from EOMAP, so our own products. They go into the exact same app, and you can also compare them to Copernicus data, for example. And then we have a nice tool, I will talk about it a bit later, called heat map tool, where you can identify areas that might be of high risk for algae blooms, for example, or also favorable for a specific habitat. So this just goes through many, many years of different variables and combines them, and you can define how this should be done. And then it gives you a heat map of where conditions usually apply that you've been defining. And the benefits of this app are that all information is in one place. We do the data curation, so we select the important data sets for you, maybe in discussion with you, of course, and we do all the maintenance. You don't have to care about anything. The data will just be there all the time. It will be updated and so on. And as said, there's a really fast process to derive valuable information from this raw data that then helps you for reporting duties, but also maybe for public communication. If there's some kind of an emergency or so, you can just log into the app, look, okay, what's the data telling me, and then maybe you use this for public communication. And then also very important, I think, is the function that it kind of supports your planning, because we talked about in situ campaigns before, and one of the constraints is that, of course, people know their area, they know where to go, where important measurement points are, but maybe sometimes it's also just a kind of a tradition. No one really questions anymore why we're going to this, why we have the station there, but why is it there? Why is it not 5 kilometers to the west or so? So what you can use the data for with this hotspot location analysis, for example, is to really dig deeper into the data and then plan better your in situ measurement campaigns, where to measure, when to measure, at what frequency to measure, for example. But now a little bit away from this theory, let's say. So these are screenshots of this app. It looks similar to many other apps, but we have some features that you see on the very top. On the left, there are these panels. We have more dashboards, and you see these white polygons similar to what we've seen in the Copernicus and the Coastal Hub viewer. So you get aggregated data. So all the pixels in these are aggregated. We take the mean or the median, and then you get these time series. And you see this is modeled data, for example, chlorophyll A concentration. You see there's 24 years of data in there for each of these points. And this is also seamless. There's no gaps in these modeled data, which is also something that we cannot provide so far with our or with any usually Earth observation data. Chlorophyll always is done with cloud cover problems. You can also look at other things that can't be measured with satellites. So phosphate, for example, isn't directly measured with satellites, but it's in these data sets. So additional information that cannot be provided with satellites usually. You can do this at several locations and compare these graphs, of course, which are nice. You can see here for the bottom temperature, for 1 year you see a seasonality, but for the yellow line, for example, there's not much of seasonality in the temperature in comparison to the others, at least. So interesting features, of course, to explore, but this is quite usual for these data viewers. What we have on top, I think I need to jump over that, is this is the baseline. What we call baseline is an historical analysis of all these years, and you get, this is bottom temperature again, so you get these informations about seasonality, about different years, about extreme years. You can compare years directly in the app, no need to download everything and write your scripts or put it into Excel. And from a more strategic point of view, we want to make we call it a one-stop shop for marine data. So we want to integrate all these data sets. So in the first place, the EOMAP's own data. So we use Sentinel-2, Landsat Planet, so very high resolution compared to some of the Copernicus data sets. They are quality checked and clouds flagged, of course, and we have 12 parameters of water quality, but we can also provide bathymetry at this resolution, so 10 or even less meters resolution, and habitat mapping. The Copernicus marine data, of course, we've talked about this all the during the webinar already, so I won't go into details here. EMODNet offers a 100-meter digital bathymetry for all of Europe, also very nice to include. It's an off-the-shelf solution, and in situ data that can be used. So all this in one app, in one shop, basically. And then I talked about the heat maps before. So what you see here is a heat map that was generated with, so you define different parameters, like in this case for seagrass, it was the bathymetry, it was the water temperature, it was the clarity of the water, and then you go through the archive of all these data sets, and then you get this map where blue means these are favorable areas for seaweed growth, and the green and orange, red means that's not really favorable. In most parts, it's just too deep for seaweed here. On the right side, you see satellite-based seagrass mapping, which matches quite nicely, not on the northern part, but on these southern parts of the island. It matches quite nicely to the map on the left, this heat map. So thank you very much. I think we will discuss further in the panel discussion and also in the Q&A session. And feel free to register here at adviceforcoast@eoapp.de, .eoapp.de, and explore some free demo data. Thank you very much.
Thank you, Fabian. And it is true, we're going to discuss more because we have some questions for you and for Marie. So yes, Marie, you also, okay. And we will have questions displayed for this panel discussion on the screen so you can see it, but I also repeat it, and then you both have time to respond to it, to share your opinion. So for first question is, how do you see the role of a coastal hub in supporting local and regional decision makers? You can go as you wish. I don't know, Marie or Fabian.
Maybe I can start.
Okay. Yeah, great.
Okay.
Sure.
This is a very interesting question, and what I wanted to show in my presentation is that for us, developing use cases is important for the co-design of our product and for the validation of this product. And we cannot create useful and usable products on our own or on the first try. And I believe that the Coastal Hub can be a tool to promote the development of the use cases using Copernicus products. And I think that this call of tender enable us to have a step closer to our end users. For us as a supplier, it helps us to understand the issues faced by different user groups. And on the user side, it helps us to understand and to have new ideas and to help us how to validate the data sets and co-develop services. So for me, it's a very useful tool for with the development of many use cases. We will be able to address many issues and to improve our products.
Okay. Fabian, what do you think?
Yeah, I can only agree. So for us, it's really important because this Coastal Hub gives a lot of awareness to the topic and all the data sets that are out there that I think many people don't know about, or they know, okay, there is something, there's all this Copernicus data, but I have never found the time to look at it really, and then it gets confusing sometimes because it's so many data sets and forecasting and reanalysis and analysis and so on. So they might just struggle with that, and then the Coastal Hub gives a first kind of a contact point with all these data sets. It's already only coastal topics that are in there, not global data sets of the open ocean and so on. There's also this connection with climate data, with the land data as well. So that's also for some applications at least very important. And yeah, it brings together all these data sets from different sources that are really important for these decision makers. And you get to see all these use cases. So even myself, I love to look at all these use cases and see what other people are doing. It's very inspiring, actually, in some parts, and it's very easy for people to connect to the data then and see, okay, all this is possible with these data sets. I didn't know that before. Kind of this this awareness that is, and taking people by the hand and tell them how this can benefit their own work. And yeah, I think in this whole uptake program, it's about creating these use cases and then in a much more specific way, targeting customers, users, decision makers in this case, how they can use this, and we're trying our best to do this, of course.
Yeah. Okay. Yeah. Thank you, Fabian. And yes, exactly. Like both of you, you presented your own use cases, and again, it's only another study case for potential users to see that, yeah, exactly, the data is available to everyone for anything you want, and that's also inspiring and motivating. So I guess we can move to another question. Yes, and it is, what are the biggest challenges you have encountered then integrating Earth observation data into coastal applications, and how have you addressed them? So basically, what are the challenges you encountered while you were working on your projects?
Do you want to go first again, Marie?
Yes, I can. Thank you. We are facing a technical challenge when we are processing Sentinel-2 data. This is the cloud coverage. But this is more an internal challenge. It's not depending on Copernicus Marine Services data. But it's very important for us to also have this data set in complementary with the Copernicus data, because if we can have a better mask for the cloud, we will be able to make available more exploitable data. And it's, for our use cases, it's useful because sometimes the end user need an image at a precise date related to the phenology of vegetation. So for us, it's really an important point of innovation. And there is also a big challenge. Fabian talked about it in his presentation. This is the collection of calibration and validation data. That is really a challenge, because we can provide new services, new products, but sometimes it's difficult to really give a confidence for these products for our end users. And for example, for the use case being developed for us with macroalgae, scientists used to work with points on the field. There is no surfacing monitoring, and to address this challenge, we developed with a research laboratory a new field protocol survey in order to obtain surfacing data that are really useful for us in order to calibrate and evaluate the Earth observation products. And in this new protocol, they do their point measurements, usually used in the Water Framework Directive, and they also record the percentage of coverage per region of interest. And with this data, we are able to evaluate the validity of our products.
Okay, thank you.
Yeah, I think that's a very valid point that we also see many times, that for many users, they know Earth observation data exists and they see benefit in it, but you also need to build trust. because they are not used to it and they are not obliged to do it. So you need to have users actually that want to go the next step and they want to try something new. But then you also have to build trust, and the validation is always a big concern that we try to address. But the sampling is usually not done at the exact moment when the satellite passes over, which is also a big problem, especially in a dynamic coastal zones. So if you're just several hours behind the satellite, or sometimes it's even days, and of course these data sets won't match. So that's one issue. It's very hard. Sometimes you can talk to the people. Okay, here are the satellite overpass schedules. Maybe you can address them, but of course that's only one part of their job, so it's not always feasible to do this. But on the other side, it's really great to convince people somehow that Earth observation is a great tool to get this bigger picture, to get more frequent data at many points, or even basically on a pixel level for large areas. On the other side, if we're not only talking about Earth observation itself, but other Copernicus data sets, like I've shown, that come from models, then one of the obstacles for Earth usage of Earth observation is, as mentioned, the cloud problem for multispectral, for optical sensors at least. So you have gaps in there, spatially and in time. And if you use the modeled data, then this is a nice way to overcome this. Of course, it's modeled, it's not measured, so there are certain constraints as well. And it also doesn't really go close to the shore. So one thing that we're trying to do is enhancing the resolution of these data sets and also bringing them closer to the shore with some extrapolation methods, for example. So these are things that we try to do to make the usage of the data even more nice for the customer, or not only nice, but fitting to the needs of the customer.
Okay, great. Thank you. Marie, if you don't have anything to respond back to Fabian, we can move to another question, right? Okay. So next question, how accessible is a Litosat dashboard to non-experts, and what support do you provide for new users? And this question is specific question to Marie. So yeah, we only will hear your opinion on that question.
Okay. Our Litosat viewer is fully open and accessible without need for identification, because we believe that it's a further step in facilitating access for a first level of acculturation about this product. And it's designed to be simple and intuitive, and we have conducted demonstrations the last years in order to present the viewer and to show the data sets and the different seasonal plugins to end users with a workshop and with webinars. This is a support we can provide. And for the next few years, we want to move forward to a more operational dashboard. For now, it's most a viewer with some functions of a dashboard, but it's more a viewer, and we really want to develop an operational dashboard that will be, of course, more complex than the current viewer. And we are going to work with user groups in order to develop these new functions, and it's going to be carried out in the framework of the national program that I mentioned earlier, with another company, with a partner, IC, and we are going to display dedicated trainings for these French stakeholders in order to training in order to explain the data sets, the viewer, etc.
Okay, great. So yeah, we can move to the next question. And this question is now specifically for Fabian. So how does the Advice for Coasts, BABAP, support policymakers or local stakeholders in making informed decisions?
Yes, so I think I mentioned it already in my talk a little bit, but let me repeat or expand a little bit. So I think the first thing is the accessibility. So if you come to us and say, okay, I'm interested in this and this and this, then we will just create this app for you specifically, and you have all the data in there, and you can directly analyze all the data sets. And we have these baseline monitoring alert dashboards and so on that just make it much easier to retrieve information from all these huge data sets, especially from if it's raster data, it's usually just it's 3-dimensional, and it's really hard to get information from it sometimes. So we try to help people in that. It's we have these heat maps that are really meant to guide you to areas where something is happening, for example, something critical is happening, which you cannot directly see from looking at one variable. So you have this 3 dimensions for each variable, and then you want to compare different variables. Okay, where do I have turbid water that is hot, and we don't, and we have a lot of chlorophyll in the water, for example, something like that. And you have to combine all these data sets, and it's a lot of data crunching for the system that needs to be done. And then in the end, you get a nice information where critical areas have been in the past, and the assumption, of course, is that they are going to be in the future as well. So you might go there for sampling. So steering sampling, in situ sampling campaigns is one of the support criteria that we want to achieve in the end. And also, of course, not only steering the in situ campaigns, but also adding to them. So as said, these point measurements, they have quite huge gaps, of course, in between. So filling these gaps makes a lot of sense, and also monitoring directly. You can, if it depends on the data set, but if you look at something, you can see, okay, what is happening, what happened yesterday, what is happening today, maybe use even forecasting. You can look into the future. So these things just help you making these informed decisions in the end. So it always needs to be based on data, but data itself is not the right format to deliver to an end client, but we need to produce information, and this is what we're trying to do. This critical last mile, it's often called, step to get to the end user, and this is what we're trying to do with Advice for Coasts.
Okay, great, thank you. I think we are done with our panel discussion. We looked at 4 questions, and we don't have much more time for that. But we will, of course, will have questions for you and for other speakers in our Q&A session. And for Q&A session, well, it's going to be Marine who's gonna host it. Marine.
Yes, thank you, Daria. And thank you very much, Marie and Fabian, for the Litosat and Advice for Coast presentation and for answering our questions. We have many more to come because we received a lot of questions from participants. So prepare and brace yourselves for that. And of course, thank you as well for our other speakers today, Muriel and Alexandre. We also have a lot of questions for you. Quickly before we start the Q&A session, if you still have questions that you haven't asked already, you can scan the QR code on the screen, or you can also click on the link that we've sent on the chat. And we also wanted to remind you that replays and presentations from speakers will be made available on the event website in the coming hours or days. We will send you an email to let you know once this is done to the email that you registered to the event with. And we will also send you a certificate of attendance by email. And we also encourage you to complete the survey to give your opinion on this webinar series. So there's a link available in the chat. If you go to the Slido platform at the top, rather than clicking on Q&A, you click on poll. This is where you can find the poll. But we'll also send the link to the poll in an email later on. Great, so we'll now begin the Q&A session. So if we can go to the Slido, please. And if you still want to ask questions, can we please ask that you specify to whom your question is addressed? It would be really useful for us to direct the question towards the right speaker. Okay, so we'll start with a question that I thought Muriel could answer maybe, and I think it's a nice one to start the Q&A. And the question is, are the people who created this website, so the Coastal Hub, in an easy way that makes it accessible for everyone, considered science communicators? And I think the answer can be yes.
Yes, for sure. Do you hear me?
Yes, we can hear you, yeah.
Okay, so indeed, the idea behind this website is to facilitate everything, and the communication is key. We didn't want to have too much science. We didn't want to have too much details, but having a very first level of information that help the users to find the best information. That's the philosophy. So I don't know if I answer the question.
Yeah, I think you definitely did, and I guess if we receive this question today, it really shows that the Coastal Hub is quite easy to access and understand how it works. So I guess that's a good thing. Thank you very much. We'll go to the next one, which I think it could be a question for kind of everyone, but maybe Fabian and Marie, if you have any answer to this question, which is mapping kelp forest and urchin barrens in Norway. Do your services offer tools for bathymetry, habitat and ecosystem mapping for restoration conservation? And I guess we could then finish to answer with someone from Mercator Ocean. Fabian, I see your mic is open.
Yes, because bathymetry and habitat definitely trigger me, because these are commercial products that we offer on a daily basis. So people are always working on that every day at EOMAP. So this is definitely something we're interested in. So please just contact me, and I will give you all the details what can be done. But I said it already a little bit in the presentation. So the good thing about all these services, and some other questions also addressed it, it's basically possible all over the world. So we got another question: is this only for Germany and so on? So the Copernicus data, sometimes for the example that I showed, we used data sets that were for the Baltic Sea specifically. There are other regions for the European continent that are in a similar way, and then there's also global data sets, and I think also other regional, but I'm not sure about this in detail. So, but generally, EOMAP services and also the Copernicus services are globally applicable.
Great. Does anyone else want to add anything on this question? Muriel,
I would like, if I may.
Yeah, of course.
Oh, okay. Regarding bathymetry, especially, I would like to say that within Copernicus Marine, we will have next November a new product for bathymetry. I think it's a bathymetry built by EOMAP that become that way a new provider of information. So I invite users to wait for November to have this new product available on the catalog of the Copernicus Marine Service, and then in the Coastal Hub portfolio as well.
Great, thank you very much. Okay, so we'll go to the next question, which I think is also, oh, do you still see? Okay, sorry. Just, okay, let's go to this one then. I guess it could be a question for everybody, but maybe Muriel, if you have an answer. Is there any data set available to review check amount of plastics in the ocean that might come from rivers or other sources?
Actually, at the moment, we do not have any source of plastic database available in Copernicus Marine Service. On the Mercator Ocean side, we do work on this. with existing database that we didn't that we do not deliver, but we prepare for the future some product maybe based on the data source, but we won't be a provider of data source. The things that we will provide in the near future, I guess, is some maybe connectivity or trajectories or simulation regarding a long-term trajectory of plastic or marine litter in general. But for the moment, we do not have that.
Okay, thank you. We'll now go to a question for Alexandre. And it's quite an interesting one. What Copernicus feature do you feel is very powerful or otherwise awesome that is underused or perhaps people don't know about?
That's a good question.
Is there anything that you haven't shown us in your demonstration that you think can be very useful?
I think that what I show is the basics. I don't really say that this is underused, but I hope people use the main tool. I will say maybe the possibility to subset the data, the way we access it easily. I don't really say that we have a specific tool underused.
Great, thank you. I don't know if Muriel, there's anything that you'd like to highlight here?
I don't know. I would say the user support must be used the most because it's a very powerful and human tool to support users. Regarding the visualization tool, they are continuously evolving. So I guess that in the future months, years, many new functionality would be added to facilitate the exploration of products. It's difficult to say what we didn't show. What is important for us is to collect feedback mainly. And so if you think that you missed something, please tell us.
Absolutely. And actually, that's a really good point. The user support team is available to answer all your questions. So when you go on the Coastal Hub website, there is small round on the bottom right corner of your screen. And if you click on it, you have access to some news. You can also send messages to talk to either Alexandre or someone else from the user support. So don't hesitate to use this feature if you have any question. We'll be very happy to answer them. Okay, thank you very much for your answers. And I guess now we'll go to Marie. I think this is a question that was asked during your presentation of Lithosat. And it is the data set from measurement or is it from observation? If it's from observation, has it been calibrated or validated?
The data set, I think it's about the vegetation index, IVS2. The data set is from observation, and it's only from observation, but the validation will come later for microalgae, where we will observe over several years some areas where macroalgae are disappearing, and here we will have training and validation data sets in order to evaluate the observation from the Sentinel-2 images. So the question is that for now it's only observation, but later it will be validated.
Great, thank you very much. I think we've kind of already answered this question, but but just to confirm, the data is freely available for the whole globe and accessible wherever you are in the world. I think the next one could be directed towards Fabian, because I think it was asked while you were doing your presentation. But if anyone else has an answer to this one, which I think it is a big one, please feel free to answer as well. And the question is, what's the solution for the water warming? We are having an invasion of Japanese seaweed affecting our ecosystem in the Mediterranean Sea. I think it's quite a big question to answer.
Is the question about the solution how to stop the water from warming, or is it about how?
I think it is.
Well, I can answer that, but probably reduce emissions. That's the first thing, but this will only help us in several decades. Maybe the solution in terms of the different portals that have been shown so far, that of course you can see it better in these viewers. You can analyze, you can go back to the past, you can compare to other years, and maybe you can also map these seaweeds. Actually, I'm not sure if they can be distinguished from other seaweed with satellites, but might be a solution to do that.
If I can add something, we are starting a national program at national level, and we are going to work on use cases and some testing areas, and we could work on Mediterranean areas. So if you want to be part of this project, we are now collecting feedbacks from end users. So feel free to contact me if you want to know more about this project and the tools we are going to develop for the Mediterranean area.
Thank you very much. I just wanted to get back to the previous question about the global products, and I think Muriel wanted to add something about this.
Yes, indeed. Regarding the global, at the moment in the Copernicus Coastal Hub, we do not have so many global products because we were focusing on European waters only for the moment, but this is a question we can discuss. Because for the European waters, we have a higher resolution product to showcase, to define the environment. This is a choice, but if people ask for our global product, we have many global products. Even if they are at a lower resolution, they can be of interest in the Coastal Hub, since when you have no other data set available. So if there is a need that we add more global product, even if they are lower resolution, it's possible, and I can change this in the Coastal Hub if needed.
Cool, thank you very much. We will now go to a question to Alexandre. Could you please show us how to download the multiple data sets rather than one at a time, or is there a tutorial we can access somewhere?
Yeah, if you don't mind, I will share my screen.
Yeah, please go ahead.
So if we go back to this window where we have the API request, this link will redirect you to the documentation on how to use the HDA API in Python. So if I just want to resume and show you how quickly we can download data with the API client. So it's just a quick install of the HDA API library. Then you have a method to enter your Wikio credentials. So if I don't say it earlier, we will need to register for a Wikio account. once it's done, you can enter your credentials here. And then you just have to replace this query with the one you created on the viewer, the Costal viewer, this one, API request. And then you have one command line to search the results and another to download in the directory of your choice. If you are if you know how to install libraries, or if you are totally new, we invite you to maybe use our Jupyter Hub, Wikio Jupyter Hub. Also, you will need the Wikio accounts, but you will have created just before. And from there, you will access a dedicated environment where you can run notebooks, and you will have the Wikio environment. I don't find it, but where the HDI API is already installed. So you will just have to run a notebook with the command we see here. And this will allow you to download, as you said in your question, not one by one, but in one command line like this. That's it.
Thank you, Alexandre.
So,
We can add the link to the article that you're showing in the chat as well. Okay. Could we go back to the questions, please? It's coming. Okay, great. Now we can go to a question for Marie. Does the Litosat interface also have an English language version?
For now, we only have a French version because our end user are French. But next year we will produce Tidal S2 and IVS2 data for South Africa and also deploy the viewer in South Africa. So we will have an English version in 2026 for Litosat.
Great news. Perfect. Thank you. Okay, I guess we can go to this one. This viewer, the Coastal Hub viewer, is the same as the one from the Copernicus Marine Service. What are the main differences? Is it the available data? I don't know if Muriel, you'd like to say a few words maybe about this.
Yes, sure. No, the viewer is not the same. The viewer within the Copernicus Marine Service is much more powerful. Regarding the available data, the catalog behind is the same, except that the fact that we make the choice to focus on a regional product and not the global one, but the global one can be added the same way. So the viewer from the hubs is different. It's only a selection of a part of the Copernicus Marine portfolio for the Copernicus Marine product. The same for the Copernicus Atmosphere, Land, and so on. It's only a selection. But if needed, we can complement the catalog with the global product. But it's true that if you want to explore the data only from the Copernicus Marine Service, I would give the advice to go to the other viewer because it's much more powerful. But the Copernicus Marine viewer doesn't allow to combine with data from the other Copernicus service. So we have to choose in between. But we guess that, we hope that in the future, both viewer will evolve to merge, to converge at a point.
Great, thank you very much. I would then like to go to a question to Fabian. Is advice for course only available to professionals?
It's in general, it's open, so you can just register. Some people already did during this webinar. You will see this one demonstration region in here in Germany, as I showed, around the island of Rügen. It's called in German. In the end, it's not only open to professionals, but we usually are more targeting customers that also have a have a little bit of budget at least. So it will not be free. So this is maybe the message here. It's rather difficult for us to provide all these data sets and these apps and all the maintenance for. We sometimes get questions from students or so. And then it's really it's sometimes difficult for us because it also comes with a lot of cost on our side to provide these apps. If that's the background of the question, I'm not sure what non-professionals means in this context, but I assume something like academia.
Yes, probably. Thank you very much. Okay, now a question for Alexandre, once again. For data sets that are 10-day weekly averages, is it possible to download statistics file, for example, a multi-year average?
So as I know, for Copernicus Marine, if you only have the 10-day/weekly averages, you will need to download them and make your own multi-year average based on this data. Maybe it's not the case for every providers, but as I know, you will need to do it manually.
Yeah,
Maybe a short add-on. This is something that can be done in our app. For example, you can do monthly aggregates. You can display them. You can download them. You can do any period you want, like a bi-weekly 10 days set here.
Thank you. The next one, I'm not entirely sure what the record in question is, but I don't know if Marie, you'd like to add anything about the availability of Litosat, maybe?
Maybe it's about the video demonstration during
I think
my
it might be
presentation.
that, yes.
And it will be available after the webinar. And I also put the link of the viewer for the pilot region in Brittany in the chat, if you can share with the participants. This way, everybody can go directly on the app.
Okay, yeah, we'll do that. So go to the chat on the event page to see this link. Thank you. Okay, won't go to another question for Alexandre just yet, but maybe this one for Muriel. Where can I find more data about the collaboration program and the details of the tender?
I think that you can find more details on the Copernicus Marine website and on the Mercator Ocean website. Maybe I can find the place where we publish the call for tender. What you can have in mind also is that in the frame of the Copernicus Marine service, we have a Marine Forum in which we have a representative of each country of the European member state and contributing state. And these representatives are aware of the call for tender long before the publication. So, and they are supposed to inform the national stakeholder. At the moment, Hungary is not represented. So if you, but maybe you have no cost, so it's difficult to for you to have somebody in the Marine Forum, but it can be done. And regarding the call for tender, I will put in the chat two links regarding the place you can find some information about.
Great, thank you very much. Okay, another question for Alexandre. I cannot export a WMS file from QGIS. Attempt to create 0 times 0 dataset is illegal. Sizes must be larger than 0. Do you have any tips on how to use such a file?
We don't have dedicated article, but I'm not very familiar with the issue you're encountering. So please contact us with the widget chat at the bottom right on the web page, the Coastal Hub, and I will deal with this with your issue.
Yes, okay.
Thank
Personalized support, perfect. Thank you very much. Okay, we can go to this one maybe for, I think it was for Fabian because this one was asked during your presentation. Are these data sets on the app enough for research or more samples are essential? Not quite sure.
I don't understand the question actually. If it's enough to be used for research, for a publication, or is that the background? I don't know. But
We can ask the person to add more details to that question if
yeah,
'cause I'm
maybe,
not
but
quite
I
sure
can,
either.
if so you can of course use all these data sets for your research. I mean that's publicly available data, and I think you can just use it and write a paper about anything you want.
Yeah, if you want to the person who asked this question, if you want to add more detail about what you meant exactly, we can go back to this question. Let's go to maybe this one. I'm not quite sure exactly how to answer, but let's try, and otherwise we'll ask for more precision as well. How will this apply to measuring shoreline change, erosion and deposit rates and beach profile over time? Not quite sure what it's about. I don't know if any of you wants to try. I'm not sure what this applies to.
I don't know about the use of Copernicus data for this, but we also do these points on a commercial basis at EOMAP. Maybe if you want to know more, just contact us. But I'm not sure about the data in the Copernicus catalog that can enable these analysis. I'm not sure. And I'm also not the expert at EOMAP for this topic. So, but you can contact me if you want.
Okay, Muriel, would you like to add anything?
Yes, effectively, we do not have things regarding the coastline, but what we have is the pressure on the coastline, meaning, for example, the waves. So we have many products related to waves, and waves, we know that they have an impact on erosion. We have also some information about the currents. So this we have pressure, but not the result of this pressure on our catalog. And maybe if you go to the other service, maybe on the land service, they may have some information regarding this to be checked.
Okay, thank you very much. Maybe we can stay with you, Muriel, and answer this one about the data being suitable for coastal dynamics in West Africa. And also, what's your advice to a researcher from the West Africa concerning developing his studies?
Okay, so I think that maybe we are going to add some global information in the Coastal Hub, so that you will have access to the whole set of data we have in Copernicus Marine Service. In Copernicus Marine Service, we have many products for the coastal dynamics. I was mentioning waves, current. We have also temperature, salinity. We have been involved in many projects, especially in Eastern Africa for the maritime spatial planning, meaning that they were needing some information, general information about ecosystem and so on. So all the variable that impact the the environment. So I would suggest you to contact us more in depth through the user support or directly me, and I can orient you. It depends on what you need for and what you call coastal dynamics. We have many information regarding the marine and we can guide you to the other Copernicus service, since we are in contact with for the land if you need other information, for example.
Great, thank you. So once again, don't hesitate to contact us through the chat widget on the hub. The next one is for Fabian. Is advice for cost available only for Germany, or can it be accessed in other European countries too? The only region available for me was, and I won't pronounce the name because I have no idea how to do
Rügen, a very
Rügen.
German word, I guess. Rügen. So I
Rügen.
think I said it before. So it is possible for all European countries. What has been shown for this one region in Germany. The Rügen is the demo region. So if you register, this is freely available. If you want to see something for your region, then please contact us and we'll find a solution.
Great, thank you. Okay, I guess this one doesn't, I don't think it's about one data set in particular, or so maybe it's more a general question about data available on the Coastal Hub. But is the data set accessible to historical data to understand the trends and dynamics? I see, Muriel, you've opened your
Yeah,
mic.
maybe I can answer about the marine data, for example. Regarding the marine data, usually we provide historical data. This is a particular product, including several decades of data, of parameters. And we also provide near real-time data, providing access to very recent data and forecasting data when it's modeling, it's from modeling systems. We also have some ocean monitoring indicators based on historical data. We can provide trends, or already computed trends over a quite large set of variables. So it depends on what you need as data sets and variables. So.
Great, thank you. We will have time to do 3 final questions before we have to wrap up this this session. So I guess we'll go to the next one, and I think Muriel, you might be the right person to answer. How can the Coastal Hub data help predict and mitigate storm surge impacts in vulnerable coastal areas, given the complexity of influencing factors? And I guess that's quite a big question as well.
Okay, it's a very big question. Actually, for the moment, the only answer we have for this is our modeling systems, since the modeling systems are able to provide prediction forecast for the next 10 days at the moment. What I wanted to mention is that Mercator Ocean was involved in a European project with many partners, and they were developing a platform, a demonstrator for a platform for coastal flooding forecasting. This platform, we are currently rerunning it. So, and the plan is to make it accessible in the following weeks, months through the Coastal Hub. This is only a demonstrator. It's not a early warning system, but it will provide many information regarding the vulnerability, the risk, the sea surface elevation, and so on. So stay tuned regarding this. But for the moment, we do not have nothing more than the modeling system providing sea surface elevation and waves.
Great, thank you. Last two questions, and I think this one is for Fabian. You've already answered the first part, I think. Is the web, but yeah, the second part, maybe you can say a few words on that. Is the web app by EOMAP available freely? How can I get to collaborate on a use case for my region? Currently already have developed workflows.
Yeah, as said, so it's not per se free. So we want to offer this on a commercial basis. This demonstration region is free to see the potential, let's say, so you can explore directly and see, okay, this is fitting for my purpose or not. Otherwise, please just contact me or any other colleague from EOMAP. Actually, just go to our website and you will find email contacts, and then we can find a solution. If it's more about an academic, I just assume if people ask about freely available, it's usually from academia. Then we will, sometimes we do it if it's attractive for us to get into a publication. So maybe if the topic is fascinating for us, then there's a chance to also collaborate on another level. But usually it's, for us, it's really on a commercial basis as a company.
Okay, thank you. Last but not least, we'll go to you, Marie, for one last question on Lithosat. What type of morphological follow-up will be proposed in the near future in Lithosat? Is it based on watercolor?
Yes, yes, it will be based on watercolor. To give more details, as part of the National Coastal Monitoring Program we are involved in, we will produce a national bathymetry product in France at 10 meters for shallow waters using radiative transfer. We will also evaluate bathymetry using waves on some areas, for areas further from the coast where we can't use watercolor. And there is also another kind of indicators on the coastline that will be developed by our contractors, IC, another French company, and they will produce a coastline from Sentinel-2 images, and also at very high resolution with the commercial Pléiades satellite. Feel free to contact me if you want more information.
Thank you very much. We have to end the Q&A session here. If we haven't had time to answer your question, we're very sorry. We'll try to answer them in a post-event report that will be posted on the event website later on. And if we can go back to the slides, please. Thank you very much to all our speakers today. We had really great presentations with a lot of questions, so I think it was very interesting to participants. Thank you for taking the time to answer all these questions as well. We just wanted to do one last reminder. If you can go back to the previous slide, please. Thank you. One last reminder about replays and poll. You'll find both of these on the event website through the menu at the top of the page. We will also send you an email to let you know when the replay is available and a link to the poll about today's webinar. And we also wanted to do a final reminder about the National Collaboration Program. So stay on the lookout for the next call for tender, aiming at developing downstream applications for Copernicus hubs. If you'd like to be a part of it, remember to check the call for tender section on the Mercator Ocean website from January 2026. And I think the link to this was added to the chat. So check this. And finally, thank you. We will be hosting the next webinar next Friday, so on the 19th of September. And this one will focus on the Arctic Hub. with presentations from people from Mercator Ocean as well, and some guest speakers who will also be presenting projects they're working on linked to this topic. So if it's a topic that is of interest to you, don't hesitate to join us next Friday at 10 a.m. Central European Time. Thank you very much for joining the webinar today. It was really great to have you here. Don't hesitate to get in contact through the Coastal Hub as well. Well, thank you to all our speakers and to participants, and we wish you all a good Friday and a good night, depending on where you are. Thank you very much.
Thank you. Bye.
Thanks
Bye,
everybody
everyone.
for listening.
Thank you.
Bye bye.
Thank you. Bye.
Thank you. Bye.